Almost all bridges have a common basic purpose, that is to carry traffic over an opening or discontinuity in the landscape. Various types of bridge traffic can include pedestrians, vehicles, pipelines, cables, water, and trains, or a combination thereof. An opening can occur over a highway, a river, a valley, or any other type of physical obstacle. The needs to carry traffic over such an opening defines the function of a bridge. We can group all bridges in the world into four basic types: girder bridge, arch bridge, cable-stayed bridge, and suspension bridge. Common wisdom suggests that girder bridges and arch bridges are good for short to medium spans, whereas cable-stayed bridges are good for medium to longer spans, and suspension bridges are good for very long spans. Hello, and welcome to Engineering Concepts. Today we will discuss about different types of bridges. Girder bridges. Girder bridges use girders as the means of supporting its deck. Girders bridges may be constructed with concrete, steel or composite material. Girder can be of any shape, U-girder, I-girder, W-shaped, V-shaped etc. and can be composed of steel, concrete or composite materials. Girder can be constructed precast and cast in place, post-tensioned and pretensioned. Girder bridges have proven to be excellent choice for rapid construction of new bridges and widening of existing structures. With no requirement for ground-supported falsework, construction usually takes far less time than compared to other types of bridges. We can further classify the girder bridges into further types based on materials and methods of construction. Precast, pretensioned concrete girder bridge. Precast, pretensioned concrete girders are fabricated off-site using pretension techniques and then transported, erected, or launched into the project site. Cast-in-place post-tensioned pre-stressed concrete girder bridges. Cast-in-place post-tensioned concrete girders are fabricated on-site using post-tension techniques and then erected, or launched onto bridge abutments. Segmental concrete bridges. These bridges are constructed by assembling smaller pieces of concrete members called segments using post-tensioning tendons to form a bridge structural system, either superstructure or substructure. These segments can be produced by cast-in-place, precast or prefabricated methods. Composite steel I-girder bridges. These bridges consist of concrete deck slab over steel I-girders. Steel girders can be welded, bolted or riveted. Steel girders are connected to deck using anchorages. Composite steel box girder bridges. Similar to composite steel I-girder bridge, these bridges are constructed using composite box girder. U-shaped steel girders are connected to deck using anchorage struts. Horizontally curved girder bridges. Horizontally curved bridges are constructed where complicated geometrics, limited right-of-way, and traffic mitigation are involved. The superstructures of curved highway bridges are usually steel I-girders, steel box girders, or concrete box girders. Highway truss girder bridges. Few trusses girder bridges are used as highway bridges today, although they are still used for railroad bridges. Arch bridges. Arch was a main bridge type for a long time. An arch bridge is usually a vertically curved and axially compressed structural member spanning an opening and providing a support for the moving loads above the opening. An arch is mainly subjected to compression and can be built with many kinds of materials, such as timber, masonry, concrete, metal, composite, and so on. We can further classify arch bridges into further types based on material and construction methods. Deck arch bridge. In this type of arch bridge, the whole structure of arch is below the deck of bridge. Through arch bridge. In this type of arch bridge, the structure of arch passes through the deck of bridge. Moment-tied arch. In this type of arch bridge, the deck beams act a tie between the two ends of arch. Fixed concrete arch. In this type of arch bridge, fixed support is provided at both ends of arch structure. Pinned concrete arch. In this type of arch bridge, pin support is provided at both ends of arch structure. Bowstring arch. In this type of arch bridge, additional cables are installed under or on the sides of deck to tie the arch ends together just like a bowstring. aqueducts and canal viaducts. In this type of arch bridge is used to carry water in open or closed aqueducts or viaducts. Corbel arch bridge. This type of arch bridge is constructed with sequential layers of masonry or stone, with every layer having successive cantilever over previous layer. Steel arch bridges. Steel arch bridges consist of concrete deck supported over steel arch. Concrete arch bridges. These types of bridges are constructed using reinforced concrete in arch as well throughout the structure. Concrete-filled steel tube arches. In this type of bridge, steel tube's skeleton is covered with concrete to form composite arch. This is one of the most remarkable implementations of composite arches. The steel tube arch acts as the skeletal system during construction, thus simplifying and facilitating the construction. Cable-stayed bridge. The use of cables as the primary load-carrying elements in bridge structures has proven very efficient, as the high strength-to-weight ratio of the cable material will decrease the escalation of the dead load otherwise related to longer spans. Due to the versatile nature of cable-stayed bridges, this type of bridge design is adopted for a variety of span lengths, from footbridges less than 50 m in length up to spans of more than 1000 m carrying traffic load. There are currently well over 1,000 cable-stayed bridges around the world. The basic structural form of a cable-stayed bridge consists of a number of triangles composed of the pylon, the stiffening girder, and the stay cables. Bridges mainly carry vertical loads, and these are transferred locally by the stiffening girder to the elastic supports provided by the stay cables and subsequently through tension in the cables to the pylons. Suspension bridge. Suspension bridges are good for very long spans. The basic structural components of a suspension bridge system include stiffening girders, main cables, main towers, and anchorages. Stiffening truss girders are longitudinal structures that support and distribute moving vehicle loads, act as cords for the lateral system, and secure the aerodynamic stability of the structure. Main cables are a group of parallel wire bundled cables that support stiffening truss girders by hanger ropes and transfer loads to towers. Main towers are intermediate vertical concrete or steel structures that support main cables and transfer bridge loads to foundations. Anchorages are massive concrete blocks that anchors main cables and act as end supports of a bridge. Combination bridges. These bridges are a combination of a girder bridge and any one of the aforementioned bridge types. For example, extradosed bridges. The extradosed bridge is a special subset of the cable-supported girder bridge. Extradosed bridge originated from French word, which means top fiber. Extradosed means that pre-stressing tendons are passing above the top fiber, thus, the function of the extradosed cables is also to pre-stress the deck, not only to provide vertical support as in a cable-stayed bridge. Stress ribbon pedestrian bridges. Stress ribbon bridge is structure formed by directly walked pre-stressed concrete deck with the shape of a catenary. The load-carrying structure consists of slightly sagging tensioned cables, bedded in a very thin concrete slab compared with the span length. This slab serves as a deck, but apart from distributing the load locally and preserving the continuity, it has no other function. It is a kind of suspension structure where the cables are tended so tightly that the traffic can be placed directly on the concrete slab embedding the cables. Movable bridges. A movable bridge, or movable bridge, is a bridge that moves to allow passage for boats or barges. Movable bridges, sometimes referred to as drawbridges, are an integral part of the transportation system. The movable bridge that was constructed. The ability to open for navigation is reflected in the terms closed and open, used to describe the position of the movable spans. A closed, movable bridge has closed the waterway to marine traffic, while an open bridge has opened the waterway to marine traffic. Highway bridges are typically designed to remain in the closed position and to only be opened when required by marine traffic. However, movable railroad bridges can be designed to remain in either the open or closed position. Types of movable bridges include vertical lift, swing, and bascule. Floating bridges. Floating bridges are cost-effective solutions for crossing a large body of water with unusual depth and very soft bottom where conventional piers are impractical. For a site where the water is 2 to 5 kilometers wide, 30 to 60 m deep and a very soft bottom extending another 30 to 60 m. A floating bridge is estimated to cost 3 to 5 times less than a long-span fixed bridge, tube, or tunnel. A modern floating bridge may be constructed of wood, concrete, steel, or a combination of materials, depending on the design requirements. A pontoon bridge, or ponton bridge, also known as a floating wartime military bridge, uses floats or shallow draft boats to support a continuous deck for pedestrian and vehicle